Ladies and gentlemen, welcome to my tutorial video channel. In this video, I will solve a problem on Cobb-Douglas production function. This is part 1 of problems and solutions on Cobb-Douglas production function. The production function is given as q equals to a k to the power alpha, a to the power beta, where alpha and beta are greater than 0, alpha plus beta equals to 1, a is positive constant, and certainly K is capital, A is labor, and A is technology. Now we have to prove two things. Number one, we have to show that the ISO-QUANT generated from this production function is downward sloping, and number two, as input rises, AP, that is average product, and MP, that is marginal product, fall. Okay, so let's get into the solution. Solution A. The production function is given by q equals to a k to the power alpha, l to the power beta. Now, the slope of the ISO-QUANT is given by dkdl, which is equal to minus mpl by mpk. The slope is minus marginal productivity of labor divided by marginal productivity of capital. Now we differentiate the production function. First, with respect to L, to find out the MPL, and then with respect to K, to find out MPK. Therefore, MPL equals to dqdl equals to ddl of this function a k to the power alpha, l to the power beta. So this becomes beta a k to the power alpha, l to the power beta minus 1. Now alpha plus beta equals to 1. Therefore beta minus 1 equals to minus alpha. Similarly, alpha minus 1 equals to minus beta. Right? So this becomes beta a k to the power alpha, a to the power minus alpha, which is beta a k to the power alpha divided by l to the power alpha equals to beta a k by l to the power alpha. Right? So this is marginal product of labor. Similarly, we have to find out marginal product of capital. MPK equals to dq equals to ddk of a k to the power alpha, l to the power beta. Here we are differentiating q with respect to k. Previously we differentiated q with respect to l. So this is equal to alpha a k to the power alpha minus 1 l to the power beta. Now alpha minus 1 is minus beta. So this is alpha a k to the power minus beta into l to the power beta. This is equal to alpha a l to the power beta by k to the power beta equals to alpha a l by k to the power beta. Right? So this is MPL and this is MPK. Now the slope is what? dk by dl equals to, that is minus mpl by minus mpl by mpk equals to minus mpl by mpk equals to this divided by this, that is beta a k by l to the power alpha divided by alpha a l by k to the power beta, right? Since this is equal to then beta k by l to the power alpha divided by alpha l by k to the power beta, right? Now you see alpha, beta, k and l are all positive. Alpha, beta, k and l are all positive. Therefore, this must be negative. Hence, the ISO-QUANT is downward sloping. K, L, alpha, beta all greater than 0. Right? So I have solved part A of this problem. Now I am going to solve part B. What is part B? Show that as input rises, AP and MP fall. Right? This is solution B. Now Q equals to A k to the power alpha L to the power beta. Therefore, APL, that is average product of L, average productivity of L, equals to Q by L equals to A k to the power alpha L to the power beta divided by L equals to A k to the power alpha L to the power beta minus 1, right, equals to A k to the power alpha L to the power minus alpha, because beta minus 1 is minus alpha, so A k to the power alpha L to the power minus alpha. Now we have to differentiate APL. We have to differentiate APL, that is Q by L, with respect to L. Now differentiating APL with respect to L, that is DDL of APL equals to DDL of this A k to the power alpha L to the power minus alpha. So this becomes minus alpha A k to the power alpha L to the power minus alpha minus 1. We have differentiated Q by L, that is A k to the power alpha L to the power alpha minus alpha with respect to L. So this is minus alpha A k to the power alpha L to the power divided by L to the power alpha plus 1. We have brought down L to the power minus alpha minus 1 in the denominator. Now since A, K and alpha are greater than 0, then this whole thing is negative. Therefore, minus alpha A K to the power alpha divided by L to the power alpha plus 1 is less than 0. This means APL is falling. Hence, APL falls. Now come to MPL. Because we have to show both APL and MPL fall as input rises. It is as L rises. There is labor. Q equals to A K to the power alpha L to the power beta. Therefore, MPL equals to dQBL equals to DDL of the production function, DDL of A K to the power alpha L to the power beta, right? DDL of the production function, that is A K to the power alpha L to the power beta. So this becomes what? This becomes beta A K to the power alpha L to the power beta minus 1, right? This is equal to beta A K to the power alpha L to the power minus alpha, because beta minus 1 is minus alpha. Now we have to differentiate MPL again. Now differentiating MPL, DDL of MPL equals to DDL of this beta A K to the power alpha L to the power minus alpha, right? As we differentiated Q by L, here we have to differentiate MPL, that is marginal productivity of labor. So DDL of beta A K to the power alpha L to the power minus alpha, right? So this becomes, when you differentiate this becomes what? Minus alpha beta A K to the power alpha L to the power minus alpha minus 1, which is equal to minus alpha beta A K to the power alpha divided by L to the power alpha plus 1. Again, since beta, alpha, A and K, beta, alpha, K and A all are greater than 0. Now since alpha, beta, A, K, L all greater than 0, therefore minus alpha, beta, A, K to the power alpha divided by L to the power alpha plus 1 is less than 0. Hence MPL falls. That is, MPL falls as input L rises, that is labor rises. So we have proved that as L rises, APL and MPL both fall, come down. Similarly, we can find out in the same way Q by K Then we have to differentiate Q by K, that is APK, average product of K, and MPK in the same way by differentiating Q with respect to K, and again differentiating that MPK, and we will find the same result, that as K increases, input falls, right? So I have solved both the parts of this problem. What is the problem? The problem is that Cobb-Douglas production function is given, that is Q equals to A, K to the power alpha, L to the power beta, where K and L are capital L lever respectively. Alpha plus beta is equal to 1. A is positive constant, A is technology, and alpha and beta are greater than 0. Now in part A, we have to show that the ISO-QUANT generated from this production function is downward sloping, that is negatively sloped, and in part B, we have to show that as input rises, AP and MP both fall, that is APL and MPL fall as L rises. In the same way, APK and MPK fall as K rises. Here we have shown that as L rises, APL and MPL fall. Exactly in the same way, you can find out what happens if K rises. Same thing will happen, that is as K rises, APK and MPK both will come down, correct? So look at the whiteboard carefully. This is enough for this video, I hope, and I believe you have understood what I have discussed in this video. Still, if you have any doubt in your mind, if you have any query, if you think that any point needs further clarification or explanation, please let me know through the comment section. I shall be more than glad to respond all your relevant queries and doubts. And if you think this video has benefited you, please do share this video with your friends so that they can also get benefit by watching this video. And finally, I will request you to subscribe and like my channel. Okay, stay well and goodbye.